Hi, today I'll be presenting about my coursework 1, which is the first order active low pass filter. First of all, filter is a circuit that could pass or amplify desired frequency while reducing the unwanted frequency. It removes some elements like noise, distortion, and interference. The four primary types of filters are low pass filter, high pass filter, band pass filter, and lastly, the notch filter. Filter can be categorized into passive filter and active filter. As you can see, this picture on the left shows an example of the design of a first order active low pass filter, which is similar to my design for the filter circuit in this particular coursework. So these are the objectives for the filter circuit design, which the filter must be able to accept the signal having frequency from 0 Hz to 1 kHz only. In this slide, you can see that on the left is my practical circuit design, and on the right is my simulation schematic diagram in Proteus 8 software. Next, we have design procedures. So, the resistance and the capacitance of the RC circuit in the active low pass filter can be calculated using the formula below. The components used for the filter circuit design are LM741 op-amp, 2 1 kilo ohm resistor, 100 nanofarad capacitor, and a 5 kHz variable resistor. For this design, I've used 1 kHz as the cutoff frequency and 100 nanofarad capacitor. So, the resistance for the variable resistor can be calculated using the formula shown below, and the calculated resistance for the variable resistor is as shown, 1.59 kilo ohms. In this slide, you can see that on the right side, there's two pictures of oscilloscope of the input and output voltage at 100 Hz and 1 kHz frequency. All the input and output voltage are collected in the table on the left side, which the gain in decibels is calculated using this formula in the middle, which is 20 log V out over V in. In this slide, you can see that this is the comparison between the simulation and practical frequency response curve graph. As you can see, for simulation, I got the gain of -3 dB, which is similar to the ideal situation. But for practical, I got the gain of -2.86 dB, which is still close to the ideal case. So I can say that this filter circuit design is a success. As you can see, there are differences between the simulation and practical. This is due to the percentage error from the noise, inaccuracy in measuring tools, and the tolerance of circuit components. As a conclusion, filter is extremely important in certain applications that includes power supply and communications. They are usually used in equalization, tone control, and preamplification in audio systems. My filter circuit design, which is the active low pass filter, can be used as audio speakers, which reduces the high frequency hiss, as equalizers and audio amplifiers. And lastly, filters are also economical and cost effective. So this is pretty much for my presentation. Thank you.